The actual data breach reports show it's getting worse. The 2015 data breach report, last year in 2014, when Verizon put out their data breach report, they said 24% of people clicked on spam. This year they found 30% clicked on. Last year, only 8% actually downloaded the malware. This year, 12% went through. So unfortunately, it's getting worse, and our users are going to do stupid things. What behavioral analytics tries to do is learn normal for those users, find the threats, raise them up at a severity level that we can identify which ones are the priority, and let us start solving the problems that our users are creating. The modules, the actual solutions, are all about learning normal and finding weird in a data set. For most companies, the stuff that gets us in the papers, the stuff that costs us millions of dollars, is around data exfiltration. Malware is a problem, but at the executive level, malware is a nuisance. Malware is send my antivirus guy out to clean the machine. But data loss, whether that's because it's personal identifiable information for our customers or healthcare records or the actual secrets to the company that you don't want your competitor to have, that's the one that is a boardroom level problem that they're worried about. Now, behavioral analytics takes in data sets and finds the weird, finds the threats, the changes of behavior that tell us that this user account is compromised, that the machine is doing something odd, and it then is about what log data are you applying to figure out the problem. This year we've expanded to include data sets and solutions around point-of-sale machines for companies like Target, large retailer in the United States. For Target, we start monitoring the point-of-sale machines. And when I say learn normal and find weird, what we're talking about is comparing all 15,000 point-of-sale machines at Target and looking for the one point-of-sale machine that's running a unique executable that none of the other 15,000 are running. I like to talk about it becoming Sesame Street. I want to be able to learn normal and find the weird. I want to point at the one that's different. One of these things is not like the others. I don't have to know the signature that says this is the zero-day piece of malware. I'm never going to know that. It's a losing battle. All of our IDSs in the world, all of our antiviruses in the world, they're trying to say, I know what bad looks like, tell me about it. With behavioral analytics, we're coming back and we're saying, I want to learn normal and find the changes of behavior that tell me this is the one machine or the one user that is doing something wrong. That lets us deal with data exfiltration at a holistic level. It's no longer about did they take a pattern that looks like a credit card or Social Security. It's about saying who's stealing more bytes, and who's transferring more bytes to the firewall than they normally do on a day. Who's looking at 10 million documents today when they normally only look at 5. It was very, very effective at GE when a gentleman named Jun Zi went out and accessed Documentum. Jun Zi worked in Wisconsin for GE Imaging Systems, for GE Medical. Jun Zi accessed, his normal was 50 documents a day on Documentum. One day he went out and decided he was going to download everything GE had on how do you build a CAT scanner or an MRI machine, multi-million-dollar pieces of medical equipment. Jun Zi was from China. He was on an H-1B visa. He had his plane ticket booked home. We caught Jun because one day, instead of 50 documents on Documentum, he grabbed 2.5 million documents. And he was looking at documents and file shares on Documentum that were about how to build a CAT scanner when he didn't have anything to do with CAT scanners or MRI machines. And we said, why is he accessing files that nobody like him accesses? That's what we're talking about with behavioral analytics. Now, as we apply that to different organizations, for Israeli Discount Bank, it's about looking at ATM machines. Why did a single ATM card get used on 50 different ATM machines all throughout Israel and Palestine within a 1-hour period? There's no way somebody was that fast at moving from ATM machine to ATM machine. We were able to spot that as a fraudulent card and see those transactions. All right. Does that make sense as a premise? We have risky users. We're looking for what their behavior looks like. We're learning what normal is and trying to identify the patterns of behavior that tell us their behavior has changed. They're doing something different, whether it's the machine or the user. As a company, we're the leader in this behavioral analytics space. We started this back in 2008. We've been working with customers like Bank of America since 2010 to actually learn what is bad behavior, what data sources do we need, how do we find threats in these data sets. We've exceeded the revenue of any one of our competitors by more than 3 times that amount, and we continue to grow a set of customers that get larger and larger and include GE, include Morgan Stanley, include Target, include these multinational organizations that realize this isn't a problem on a single user level. This is a problem that crosses all of our users across the world, across very large organizations that meant we had to learn how to do this at scale. Now, the way we solved the problem, because I don't think you guys care that much about who SEGURANCA is yet, but the problem, the stupid user problem we all have, we all sympathize with. The way you start solving the problem is by taking in data sets. Now, the easiest way to take in a data set is from the existing log management solution that's there today. So we're going to reach into the Splunk or ArcSight or QRadar or whatever the SIM tool is, the log management tool, and get a copy of about 60% of the data that we need. The tools that cannot touch your SIM, and there are other competitive tools in this behavioral analytics space, if they can't reach into your SIM, the problem is you're going to have to go out and redeploy agents and get all of those log sources pointing at your new tool. And if you've done a SIM project, and I did hundreds of them for about 10 years, that's a long project. It's a long time just to get all the right log data in. We start by getting 60% of what we need from the SIM, but it's not enough. The next thing we're going to do is reach into the identity. If we're going to look for a user-based problem, I need to know who the user is. If I'm going to figure out normal and weird, I need to know how to compare one user to another. And hiding in identity data, data sets that the security team hasn't usually had, is all of the data that we need. It has things like department and division and location, job code, all of the little points that let me compare you and know who else is like you, so that I can now start looking for, why do I have a database administrator that does a wire transfer to an account in the Grand Caymans? If he's the only database administrator out of 5 people in my company doing that one transaction, wire transfer, I expect database administrators, I can see that they all, through the logs, they create tables, they drop table, they alter table, but this one guy out of 5 does wire transfers every Friday for $9,999, so he doesn't hit the IRS limits and the international reporting on, oh, I've got to tell you how much money was spent. And he uses an account number in the Grand Caymans that nobody else in the rest of the company has used. I can now start saying, that looks like fraud. That's financial theft. And it's not financial theft because I said, if he does this, I simply said, tell me when he does something others like him don't do. And it starts showing very quickly and easily who the problem children are. Now, the other thing that we want, the other 20% of the data, so 60% will come from the log management that's there today. If there's not one in place, we can't collect all that data directly. But if there is, we're going to use it. 20% will come from identity tools. We'll reach into the provisioning system, whether that's Kurian or Active Directory, however they're creating and managing their users, we'll reach into that tool and learn who they are. 20% will be from the applications. As a business, it's less important whether I get malware than it is about whether I'm having somebody steal money. It's less important about, the latest virus or spyware than it is about whether somebody is stealing hundreds and hundreds of files that contain how do I build my key tool. With Pfizer, one of our customers in the pharma industry, we start looking for who's accessing the compounds, the records that tell me how do I make a little blue pill that makes Pfizer $4 billion? Who's interacting with that data? And what are they doing with it? And now I start watching at Pfizer, are you emailing after accessing our critical compounds somebody over at Merck or Eli Lilly, one of our competitors? Because if that little blue pill happens to show up at Merck or Eli Lilly with the same exact compound, they now start making billions of dollars and we lose a lot of money. So we're looking into that key application. And I would tell you with any behavioral analytics tool, if you're going to be successful, if you're going to show value at the executive level, the most important thing is to get the transaction data for the application that's important to the customer. Where does your data live? Who's interacting with it? That's what's going to help me find the real threats that matter at the executive team level. Everything else to the right is just variance on the data. One of my rules of thumb is for every log source, there's a complement. So if I'm going to pull in firewall data, we're going to reach into what we call TPI sources, Anomaly, McAfee's GTI threat stream, lists of blacklists. These are known evil IP addresses. These are known malicious command and control channels and URLs that are known to have malware on them. So what I can now say, if I see a firewall accept from an internal machine to somebody going on the outside world that's on a known blacklist, absolutely, that's bad. That's a machine that's showing symptoms of malware or leaking data that I really care about. Those are easy. As I start looking at vulnerabilities, at IDS data that tell me about a signature, a threat that occurred, I now start looking at vulnerability scan data. Is the attack that IDS is telling me about something that the asset is vulnerable to? So for every log source, there's a complement. And we start then learning a profile. What does normal look like? Now, this is where the secret sauce to every product comes into play. We apply unsupervised machine learning to the log source data to figure out what normal looks like. We apply a bit of artificial intelligence to try to determine what is normal between users, what is different between users, but all of that comes out into a set of things that say, what is normal for you? Which IP addresses do you log in from? What transactions do you execute in each application? How often do you execute those transactions? What is your unique username in each application? An underpinning and a reason we wanted the identity data, and I'll show you in the tool, is that a user, a single heartbeat, usually has 5 or more different accounts on the different applications in an organization. So I actually have to learn who you are. I can't assume that you're always logging in and you always appear in the logs as John Smith. Sometimes you'll be J. Smith. Sometimes you'll be John Dot Smith. Sometimes you'll be JS1234. And we learn that as we get data fed into the system. Amount spikes. Amount and frequency. Well, frequency is how many times did you do how many failed logins did you have today? Amount is how many dollars did you transfer through that application today, or how many bytes through the firewall. Once I learn normal, finding the weird is easy. The weird simply looks for the spikes. Now, a couple of unique behaviors that are functions of SEGURANCA that I don't believe any other tools deal with. We also start looking for robotic behavior. Why do I see 300 keystrokes through CyberArk's PSM module that tells me you've got a critical service account checked out, and you just did 300 keystrokes in 1 second? Human beings can't type that fast. Why are you the one machine that connects every 10 minutes on the hour to this foreign IP address in Russia that nobody else is connecting to? It's that pattern that says every 10 minutes on the hour for 24 hours a day for 3 days in a row. I know that's not a human being. Human beings aren't that predictable. The other one, dynamically generated algorithms, DGA. We're actually looking at the URLs that, as we pull in proxy data, to look for things that tell us it's a random character string. Human beings go out to myhomepage.evil.com. They don't go out to xyk9462254.evil.com. They're going to type in something that's human readable. And we're doing analysis on the URL to look for random strings. We're doing analysis on the actual domain they're going to and looking up at the registrars at Aaron and Ripe and Apnic. When was this domain registered? Because there's a common symptom of advanced persistent threats. We want to move the command and control channel around, so they're constantly registering new URLs out with these DNS providers and saying, now if they search for this random string, send them to this URL. Tomorrow, send them to a new IP address, to a new home URL. That moving command and control channel is the thing that's really hard to spot in APTs. It's called fast flux DNS. And the symptoms tend to be these random character strings that people register with the search providers, and these moving URLs that mean it's very difficult to find that this is an evil guy because he's not on the same evil IP address tomorrow that he was on today. So those are the techniques that we start applying, and it is learn normal, find weird. We can deploy this in 2 models. For our smaller customers, we deploy on MySQL. We can do 3,000 events per second per child node. We simply add more child nodes to deal with the scale. for our larger enterprise customers who may want to replace their SIM or their log management tool, we can deploy on Hadoop. And we sit on top of Cloudera's implementation of Hadoop to provide you a full clustered model with high availability that can search for events in the tens of billions of events per second category. And we simply add ingestion nodes and HDFS storage nodes called analytical nodes to be able to scale this up to store as much data as you want and to sit on top of a data lake, allowing you to read and write to the Kafka message bus as a subscriber in Hadoop terms, so that I can reuse a data lake that may already exist. I can share that data with other customers that are subscribing to that Hadoop model. So that other customer may be the security operations team, or it may be the network operations center. It may be the business analytics department, all within the organization reading and writing to the same data set. What we pick up when we move into the Hadoop model is this natural language search that we call Spotter on our Sniper deployment. And the really cool thing about this, unlike previous models, as we've moved to Hadoop, the challenge we've really had has been the data set is so basic that you can't answer the questions that business analyst wants. In Hadoop, most of the implementations, whether you're talking Splunk's version, which they call Hunk, Splunk on Hadoop, or you talk about the open source model with ELK, Elasticsearch, Logstash, and Kibana, what they actually store is only the very bottom piece, that raw event that has the IP address and the actual executable name or the image that contained the executable. But when somebody comes to my SOC team, to my security analyst, and they ask me to search for a problem, they don't want to know about an IP address. They don't want to know about a specific piece of malware. What they want to do is ask the question, is anybody in my sales team emailing large files to one of my competitors? Well, wait a minute. That's a difficult question to answer if all I have is the raw data. And that's the problem we've had with Hadoop implementations today. All they had was that raw piece. With Sniper, with SEGURANCE, what we actually do is super enrich the data even before we write into Hadoop. So I look up and I overlay. Is this guy on any known blacklist? I look up threat intelligence data. I look up DNS information. What location is this coming from? I look up the user information and overlay it. What department is this user in? What's the actual user's name? Not just the IP address, but who was logged onto that IP at the time. What department are they in? What do we know about them? What do we know about the IP addresses that they're communicating with? So that when I'm asked to search for sales, I simply write a query that says, tell me if anybody in sales is sending large files. And it returns that data from Hadoop because it's already enriched in the data set. And now I get very usable language, very usable data sitting out in Hadoop that I can scale to any size that I want. All right, that's it for slides. I don't want to overload anybody on slides. If you're like me, I get bored to death with slides. I'm a technical person. I have over 30 technical certifications, including incident handling and intrusion analysis and network auditing. And when people load me to death on slides, I tune out and go to sleep. My official corporate slide has 46 slides, and I always offer death by PowerPoint with my 46 corporate slides. And in 2 years, I've never had anybody take me up on it. This is what we're trying to get. This is the results. This is the interface. If you're seeing my screen right now, you should see the security dashboard. From the left-hand side, it just has different dashboards and different ways to jump into the data so that we can look for how we find the data. From the right-hand side, what we see at the top is a summarization of who are my highest risk users, my highest risk uncorrelated accounts, those service accounts that every security admin in the world who creates a machine kind of hides in the system. The first thing I want to do is create a service account that can log in locally in case my network authentication fails. My high-risk machines that are showing symptoms, because the same symptom could be attributed to both the user and the machine. It may not just be the user that's a problem. It could be the machine that's showing symptoms and no user on it, the point-of-sale type of machine. And the external machines with 76 external IP addresses showing symptoms of attack. Now, as I look at what an attack looks like, I'm going to drill into Kevin Milton because this is data exfiltration. This is the biggest problem that most people are looking for. I want to point out a couple of things. First off, each user is given a risk score. Every single event is scored with a risk value. How unusual is this if it is unusual? If it's not, it gets a 0 score. It's not even alerted on the dashboard unless we simply mark that as something that's very interesting that we want the analyst to know about. But by doing this, what we end up with these risk scores, and our top 3 are already 2 orders of magnitude summarized versus what we would see in a SIM tool, like an ArcSight or QRadar or a Nitro or a logarithm. Instead of 95 individual events, we have 1 user being identified as a threat. There's a trick to doing this, and this is the trick that all behavioral analytics tools, if they're going to do user problems, have to solve. I'm going to launch what we call our investigation workbench. This is a drag and drop tool that lets me pivot and see what my user is doing. It lets me wander through this user and pivot on any point within the user to see who is he, what do I know about it. Take any one of these nodes and left click and pivot. But this is the first problem. So the first question I asked it was, what accounts does Kevin have? Where do I see log data for Kevin? And this is the problem behavioral analytics had to solve first. As he comes through the SharePoint server, he's KM1015. But in some tools, he's 1015, his employee ID. In others, he's K Milton. He's Kevin.Milton in the SharePoint log. Usernames are not normalized across all the log sources. So if we try to correlate at the user level, it's going to fail in most tools. Until we get to a SEGURANCE and to a user behavioral analytics, we don't know that these are all still the same user as he moves from one machine to another. In fact, a lot of the log sources that we get, like Firewall and NetFlow, don't even have a user field in them. And what we have to do for those log sources to be able to attribute those IP-based events back to the user is build tables that say who was on that machine, who was logged in at the time the event occurred. And then as we see IP-based information, we dynamically associate it to the user. That's how we start solving that user-based problem and finding who Kevin is, regardless of which application he's on, regardless of which username he is. Then the second trick that we're applying to this data, as I look through Kevin, I start adding a risk score for each individual event. In SIM tools, we've had this problem where it took very high-level people who really understood the tool and understood security very well to correlate the data across these log sources. And it was very painful to maintain those rules. Gosh knows I've implemented hundreds of them, and my customers 6 months later aren't able to maintain the content that I built for them, and I got frustrated with that. In behavioral analytics and SEGURANCE specifically, by rating it as a risk score across each one of these and correlating that up at the user level, I don't have to build crazy complex rules. I simply build a rule that says, tell me if he does something weird. And when I say tell me if he does something weird, what I do is take a source like SharePoint data. SharePoint data looks pretty horrible because all it tells me is user A accessed file B. They did a file download on file B in SharePoint. And goodness knows we all have this unstructured data sitting out there, whether it's SharePoint or Documentum or Perforce or whatever your favorite tool is, as to where you store and share files. And as a security team, we're asked to protect all of this, but we're not told who's supposed to access what. So we need the tool to be smart enough to learn normal and find that weird. And as we apply that, what we start saying is, well, wait a minute, this is why it's weird, and this is being flagged as a risky event, not because somebody told us which files Kevin's supposed to look for, but because we know that Kevin, based on identity data, has a title of Associate Data Services. Kevin is in the Department Data Services. And with that title, there are 11 other people that share that title, and he's the only one to ever touch, out of those 11 people, these files. He's one of only 2 out of 27 people in the entire department to touch the files. And as we start seeing the files, user A access file B, well, he's grabbing our sales documents, he's grabbing projected updates, memorandums of understanding, financial documents. Why is somebody in our IT department grabbing all of our financial documents? This starts to look odd. And the tool's smart enough to dynamically apply and do data classification to say, that doesn't look right. This is what looks weird. So as we see those terrible log sources like SharePoint, but where we actually store all of our critical data, I can say this is odd. Why is he grabbing a whole lot of documents on files that nobody like him has ever touched? Then we get into the traditional DLP. So we start seeing and collecting those log data from things like Semantic Endpoint or McAfee or Vontu. Pick your favorite tool, and now it starts telling me that Semantic tells me we did our job. DLP blocked this event. Symantec says, yep, it looks like it was data exfiltration, and we went ahead and blocked the right to USB drive. Great. Like most users, Kevin Milton's going to say, yeah, so what? There are 7 other ways I can steal the data. If you block it to USB drive, you know what I'll do? I'll just go ahead and email it to myself. And our spam tools, our ironport logs also tell us that, hey, it's okay because it wasn't a virus and it wasn't malware and it wasn't spam. I'm going to go ahead and allow that out. And ironport says, see, we did our job. We prevented malware. But the data was still left the organization, and we still have a data exfiltration problem. Now, we didn't want to identify this just because he's sent to himself. In fact, what we're doing is a little bit of sender analysis. So we see this email, and it says, well, that's his last name. The email destination contains his last name and his first initial. Great. I can auto-attribute that and say, that's his personal account. And I'm not going to flag just because he emailed his personal account. But what I am flagging on is the fact that he normally emails his personal account about 11 times a day. Why did he email 59 times file attachments to his personal account today? It's a spike of 6 times his normal amount. This guy's trying to figure out a way to get the data out, and he's found one. So while Symantec told us that it was blocked, ironport told us it was allowed, and all SharePoint told us was, here's what he accessed, and it was a whole lot more and a whole lot of documents he probably shouldn't access based on identity data. And the system's smart enough to say, that's cross-channel data egress. That's the guy that now actually got intelligent enough to figure out it was blocked on one channel, and the actual, not only do we pivot on file, or on folder and user, we now pivot on file. And we say the same file that was blocked one method was then allowed with the second. So it was blocked on USB and then allowed on email. This becomes a holistic picture of user threats. I'm no longer dependent on whether it simply looked like it matched a DLP pattern in a non-encrypted file over a non-encrypted channel, because DLP has so many limitations. It doesn't say this is a regex for a social security number or a credit card. It says this is that user that was going, by the way, I didn't even mention, but all the predictive indicators, he was doing a job search. So American Express asked us to look for who was likely to be stealing data, and we look for in proxy data, this guy's looking for a new job. He's hitting Monster, he's hitting Ladder, he's hitting Yahoo Jobs. Great, oh crap. And then he actually grabs a bunch of files that he shouldn't. He tries to write them to USB drive. He emails them to himself and finds a vector that's allowed out. And he actually goes ahead and posts them to every external storage site he can find. The system's smart enough to say, that's the user that we need to go get off our system. We need to have legal talk to. We actually need to file an incident on. This is my high threat user. And it's not because they matched an IDS signature or a virus. They didn't do anything they're not allowed to do. The tools did all of their jobs right, and yet he still stole the data. That's data exfiltration at a high level, and that's what we're talking about with behavioral analytics. Look at the user's behavior, find when it changes, add all of those changes together with a risk score. So what I can say, these are my high-risk users. Anastasia, Patricia, and Kevin all have more than 95 individual events that tell me their behavior has changed. They're well past the 3 strikes rule. It's time to go get them off my network and talk to these people because there's problems. These accounts are either compromised or intentionally stealing my data. And I don't care which, but I have to prevent them from taking my corporate secrets. Now, we can look at that data 10 different ways to Sunday. So I can start going and looking at it at the service accounts. And the one that I usually like to show, I don't want to overload you guys, but one that I do like to show you is for that database side, because we don't all have the same log sources. But if I look at a service account that the identity team didn't even know about, this is one of those service accounts hiding in my logs, and I see the service account do an interactive login, a keyboard-based login on Windows, something a service account should never do. And then it's logging in from an IP address on top of that it's never used before. So it's being used somewhere weird in the organization. And then the coup de grace, the big and nasty one. The same service account, as it comes through Guardian logs, my database logs, tell me that this particular account just did something they've never done before. They did a select star on my customer master table. This is what cost Sony $1 billion when the PlayStation data breach occurred. They grabbed every credit card record for every PlayStation holder throughout the world. And they now had all of my PlayStation account holders. Sony lost $1 billion market cap overnight and spent $250 million in breach response and litigation. This cost, and I worked with all three of these organizations on breach response, Experian and Epsilon, both lost over $4 billion when an internal user who had joined the organization did a select star on the customer table, and then, like every hacker, delete from audit log where like SVCDB backup so we can try to hide it from the forensic logs. And this is all being identified not because we said we know which user's not supposed to do this. In fact, with most service accounts and most tools, what we do is whitelist them and say, yeah, they trigger all kinds of signatures, we'll just ignore everything from that account. In this case, we said, don't ignore the account, learn what normal is, and watch when the account does something for the first time that they've never done. And as they do things that tell us they're doing multiple things they've never done before, we have those indicators of change that we add together to say, this is an account that's being misused that just stole our data. Now, it gets better because from an investigation team, that investigation workbench I was showing you, I don't need to know just the service account. I want to know where was it used from. I want to know which IP address is what was used on. And I can do that pretty quickly in the interface by simply pivoting on and saying, show me all the events that apply to that user. I can see the IP addresses that they've used. I can then pivot and say, show me the accounts that have been used on that particular IP address. And I can see it's just service accounts except for this one Windows login account called 1014. I can open side by side a new investigation. My little VM's a little bit slow. Side by side a new investigation, and then I can ask who are the users that actually log in using that account. And now I've traced back to a service account misuse that stole our entire database, figured out which account it occurred, which IP address it was done on, and who else had logged into that IP address other than the service account. John is the only one to ever physically log into that machine. So that keyboard-based login, guess who else was physically on the machine at the same time it occurred? Who do I go serve a warrant? Who do I go get off my network? Well, John Keller. And I've now taken, identified the threat hiding in our data with the service account because it executed commands it's never done, identified the machine it was used on, and identified the only other user to ever log on to that machine. I can say that's the guy that used that account wrong on that date and stole our entire database. So that's it, guys. I want to let you guys ask a few questions. So I'm going to pause and turn it back to the NetBR team to provide translation. So I apologize for not speaking Portuguese. But if you'll help me with the questions, I'll be glad to answer any of them now.
Thank you, David. I'm now speaking Portuguese. Pessoal, muito obrigado. A gente pegou e tomou nota aqui de todas as dúvidas e vamos dar sequência entrando em contato e esclarecendo-as. Mais uma vez, muito obrigado. A semana que vem a gente tem mais um webinar da série de resiliência digital e contamos com vocês aí para mais uma discussão sobre os assuntos de segurança. David, again, thank you so much. We took note of all the questions that the customers they had, and we follow up by email here. So thank you.
Obrigado. Thank you for having me. Have a great day, everyone. Thank you for your time.